In this segment we are going to look at problem 1.2 from Metzenmacher and Opal. This problem is called the Monty Hall problem. To give you a bit of background, Monty Hall was a game show host, and in that game he would play this the following random probabilistic game. So, let us think of this, let me explain this context. So, there are in this context there are 3 doors. Okay. And what you know is that behind one of these doors, D1, D2, D3, behind one of these doors is a special prize, let us say a car, and behind other 2 doors there is something a lot less desirable. Let us say according to the problem given here, behind other 2 doors are goats. Okay. So, obviously you prefer a car which is a lot more expensive and valuable, and so your interest and you are allowed to choose a door. Okay. And let us say we pick door D2, and then the game show host Monty Hall, he is aware of which door holds the car. Okay. So, he can look at your choice, and so this choice may be the choice with the car, it may be the choice without the car. We don't know, but Monty Hall knows that. But regardless, one of these other 2 doors is going to have a goat. Okay. So, what Monty Hall is going to do is open the door which contains a goat. So, this okay. And now he gives you the option. You have 2 options. One, you can either retain this D2 or you can move to D1. So, there are 2 options. Now, you have the freedom to choose D1 or D2. Okay. And at first you may think there is not much value in choosing in moving over to D1. Maybe you might be saying, well, why don't I stick with D2? But as it turns out, you actually increase your chances of winning the car by moving over to D1. Okay. And this is the Monty Hall problem. We need to prove that this is in fact the case. Okay. So, let's try to analyze these 2 scenarios. One scenario, you choose a door, Monty Hall reveals another door where he has a goat, but you choose to stick to D2. That is scenario 1. You retain your choice. Okay. And scenario 2, you switch. So, in scenario 2 you would say, well, I chose D2 early on, but let me give up on D2 and switch to D1. Okay. And at the end, whichever door you have chosen is going to be opened up, and you are going to get the price that is held behind that door, and obviously your interest is to get the car. So, now we have to analyze these 2 scenarios and figure out what is the probability of getting a car in either of these 2 scenarios. Okay. So, what is the probability of getting a car under scenario 1? Well, if you think about it, in scenario 1, you are going to choose a door uniformly at random between say D1, D2 and D3, and you are going to stick to that. So, probability of car in scenario 1 equals 1 over 3. Okay. What about scenario 2? Scenario 2 is a little bit more tricky, but let us think about what happens in scenario 2. Okay. There are two possibilities that could have happened. One is your first choice in this particular instance D2, your first choice could have been a car, and if that had been the case, you lose. Okay. But on the other hand, the other scenario is the first choice that you made was not a car. Okay. And remember, and if this was a goat and Monty Hall has to reveal the other door that also hides a goat, then the third door that you are going to choose in fact has the car. So, if you had started out with choosing a door that is not hiding a goat, rather choosing a door that is hiding a goat, then you are going to necessarily win the car. So, these are the two cases that interplay with each other. So, let us analyze them a bit carefully. Okay. So, let us write out the probability that we are interested in. Okay. This is the probability of winning a car in scenario 2, that this is our interest. Okay. Let us see the two cases. So, there are two possibilities. First choice is car. Okay. And under this first choice being a car, the probability of winning a car becomes 0. Okay. The second scenario is so then probability that first choice is a goat. Okay. And if your first choice is a goat, let us see what happens. If your first choice is a goat, this you are going to move into the other door, which is necessarily a car. So, this is going to be times 0.1. Okay. And what does this work out to be? The probability that the first choice is a car is 1/3, but it's times 0, so that essentially does not matter. And then the second option is that the first choice is a goat, and that is going to happen with probability 2/3. Okay. And if that is the case, you necessarily win the car, and that is with probability 1. Okay. So, this works out to be 2 over 3, and notice 2 over 3 is significantly better than 1 over 3. So, what this tells you, and might be a bit counterintuitive, and you may need to think about this a little bit. What this tells you is scenario 2 is significantly improving your chances of winning the car. And so, this is one more example where careful analysis of this sort of a randomized situation reveals something that could be a little bit counterintuitive. It certainly was counterintuitive for me. So, that is it.